Hello everyone, my name is William and we're gonna solve problem 6.22. We're not gonna plot it, okay? I think that takes LT Spice, so I'm just gonna skip that part. So step one, we're gonna analyze the circuit at T, oh my bad, T is equal to 0 minus. So the 12 volts is connected to the resistor, and then we're gonna assume steady state, right? So the inductor acts like a short, so there's not gonna be any current going through here, okay? So gonna be, and since there is no current going to the capacitor, capacitor voltage is 0 volts. And now we're gonna find IL. It's gonna be 12 volts over 2 ohms, 6 amps. All right, so T minus. At T0 plus, continuity applies. Voltage of a capacitor cannot jump. Current through inductor cannot, cannot jump either. Okay. All right. Now we're gonna try to find I prime of, well, let's analyze the circuit after the switch is open, right? So we see that the capacitor is connected to the inductor. There's no current over here because this is open right here. So no current going through here, So the capacitor is in series with the inductor, also in series with the resistor, right? So from here, I want to find IC prime of 0 plus. But I want to mention that since these components are all in series, they share the same current. So IL 0 plus is equal IC 0 plus is equal to IR 0 plus, right? Now to find IC prime of 0 plus, I'm gonna do a KVL right here. So IC prime 0 plus is gonna equal to, well, actually do the KVL first. Right. So it's going to be 2 times di dt plus 8 times IL 0 plus VC at 0 plus is equal to 0. Now we already know what IL 0 plus and VC 0 plus is. So we can just plug that back in. So 6. This is going to be 48. That's 0. So oh, I already did that part. All right. So now that we know that what the IDT is, since IL, IC, and IR are all the same, so I prime of C, let's see, at 0 plus is equal to negative 24. All right, this is important. We're going to use this later. Okay, now, since I already mentioned, this is a series RLC, so we're going to use the series RLC formulas. Okay, so alpha is equal to, excuse me, R over 2L is equal to 8 times 2. Oh shit. 2 equals 2. W naught is equal to 1 over square root LC, which is equal to 1 over, skip it, 2 times 0.1, 2.3, nope, 236. All right, and since we're already at it, let's just do WD. Square root W naught squared minus alpha squared, which is equal to, so 2.236 squared is roughly 4.9996. So I'm just going to write that as 5. 5 minus 4 equals to 1. All right. Now, from here, we see that W naught is greater than alpha, which means that this is a underdamped response. Okay. And for the general formula for the underdamped, we got ICT is equal to e to the negative alpha t a cosine WD t plus b sine WD t. Right? But we already know what alpha and WD is, so we're gonna get IC of t is equal to e to the negative 2t alpha cosine t plus b sine of t. All right, cool. And these are all in amps. Okay. Now, since we know that IL 0 plus is equal to IC 0 plus, right? Which is equal to, and we're gonna plug in t equals 0 to the general formula, which is gonna give us, right, e to the negative 2 times 0 a cosine 0 b sine 0, right? Amps. And earlier we know that IL of 0 plus is equal to, right here, 6. So we can just plug that in there. Right here. So after plugging in, this is going to equal to 1. That's going to equal to 1. This is 0. So it's just, we're going to be left with A is equal to 6. Okay. Now we found A. Now I have to write down the general solution for IC prime of t, right? And you can use the product rule to find the general solution for the derivative. I'm just going to use the calculator. It's more accurate. You know what I'm saying? So IC prime of t is going to equal to e to the negative 2t, negative 2 alpha, negative 2a cosine t minus 2b sine t minus a sine t plus b cosine t. All right. Now we know that IC prime of 0 plus. So we're just gonna plug in everything to be 0. So it's gonna be 2 times 0 cosine 0 2b sine 0 So after, that's 1, that's going to be 1, that's going to be 0, this is also 0, and this is going to be 1. So what we're left with is negative 2a plus b. And now, since we already found what IC prime of 0 plus is, right, which is negative 24, right here, we can just plug that back in. And we also found what negative 2a, well, we found what a is as well, so, which is going to be 6 right here. So we're going to get negative 12 is equal to plus b is equal to negative 24. B is equal to negative 12. And that is going to be, let me see, I think that is the final variable we have to find. And now we just plug everything back in to the general formula. So IC of t is equal to e to the negative 2t, right, times cosine, hold on. A, right, A, 6 cosine t plus minus 12 sine t. And that is the solution. So, wow, I wrote small and got bigger. Okay. So that completes problem 6.22, right? We found IL at 0 minus, right? Which, because of the continuity, we also find IL at 0 plus. We also found VC at 0 minus, which also gives us VC at 0 plus. And with that info, right, for the VC, we plug that into our KVL. We find out what dIdt is. And we found out that dIdt is equal to -24, right? And we save that info for later. We analyze the circuit, right? We realize it is a series RLC, right? So we use the parameters for the series RLC, right? And then we found out it was underdamped. So with that information, we use the general formula for the series RLC underdamped, which is right here. And we plug in 0, right, to find out what A is. And then we use the derivative of the general formula, right? And we plug in, make it equal to -24, and we find out what B is. And we use plug A and B back into the final solution, right? And we have our answer. Thank you for watching.